All right, section 2. Hopefully we're ready to go. We're going to continue talking about some areas. This time we're looking at trapezoids, rhombuses, and kites. So just a quick refresher on what those are. Hopefully you remember these things from chapter 8, but just a quick refresher. Trapezoid means has exactly one pair of parallel sides. And the important thing to remember with these is the pair of parallel sides is what we call the bases. So the bases are the parallel sides. Remember that that double line right there is the symbol we use for parallel. Rhombuses have 4 congruent sides. And kites have 2 pairs of consecutive congruent sides. Okay. All right. So here we go. Here's the formulas. The area of a trapezoid is half of the height times the 2 bases added together. Okay. Half of the 2 bases added together and the height. All right. And you'll notice that the area of a rhombus and the area of a kite, the formulas are the same. So the formulas to find the area of a rhombus and the area of a kite are actually the same. And that's because the reason why these formulas work is because of something that is true about both a rhombus and a kite. So going back to chapter 8, some of the properties we learned about those shapes. So when you have a rhombus, one thing that we talked about is that the diagonals are perpendicular. And so what you actually make is really 4, but you can look at it mainly as an upper triangle and a lower triangle. And then those diagonals are also bisected. And so basically finding half of 2 triangles. And then same thing here. So a kite oops, messed up that notation there. Should be 2 here and 1 here. Sorry about that. So again, those diagonals are perpendicular, so you can kind of look at it as 2 triangles. This diagonal added together becomes your base or your heights of the 2 triangles. And so that's why these 2 formulas work. And so the formula is half of the first diagonal times the second diagonal. And it doesn't matter which one you make your first diagonal and which one you make the second diagonal. And so I have down here the D1 and the D2 stand for the diagonals. And then up here, the B1 and B2 stand for bases. And remember that trapezoids have 2 bases. Okay, and the bases are the pair of parallel sides. All right, so you looking at those formulas, let's go ahead and dive in. All right, so here is a trapezoid. Finding the area of a trapezoid. The free throw lane on an international basketball court is shaped like a trapezoid. We want to find the area of the free throw lane. So we're told it's a trapezoid. We can see that these would be the bases. So again, the formula is half of the height times base 1 plus base 2. Remember, height, anytime we're talking about height, whatever the case may be when we're talking area, height must be perpendicular. If we're talking about the height, it has to be perpendicular. The actual height is perpendicular. All right, so there's always got to be that perpendicular about it. Okay, so the height, we can see that this is perpendicular to the 2 bases. The height is 5.8. The first base, and it doesn't matter which one you make the first base, which one you make the second base, because you're adding them together. Okay, so one base is 3.6 and one base is 6. So we plug all that stuff in. We get half of 5.8, which is your height, and then 3.6 plus 6. So first thing you do is you add the 3.6 and the 6 and get 9.6. And then you take half of 5.8 times 9.6 and you get 27.84. And so the area, we're talking area, so it's going to be squared, units squared. And here we're given the units, so we use meters, meters squared. All right, here we have a rhombus, which is one of the inlays of a guitar. So find the area of the inlays. Now you want to pay attention. So to find the area of a rhombus, we need to take half of the two diagonals multiplied together. The only thing that you really have to pay attention to on these is make sure that you use the whole diagonal. Okay, sometimes you will be given the whole diagonal, sometimes you'll be given just one section of it. Now remember, with rhombuses, since rhombuses are a type of parallelogram, the diagonals bisect each other, so we know that's the same as that, and then this one right here is the same as this one right here. Okay, kite, they don't bisect each other, but one of them is bisected. The one that connects the two congruent angles will be bisected. So just kind of keep those things in mind. So here, we're given this length right here is 9 millimeters, which means that the actual diagonal is 18 millimeters. And then you can see this arrow is going to just this section, so the actual diagonal there is 24 millimeters. And again, just like with your bases, your base 1 and your base 2, your diagonal 1, your diagonal 2, it doesn't matter which one you make 1 and which one you make 2. You just need them both there. So rhombus, we're going to take half of 18 times 24. Half of diagonal 1 times diagonal 2. And you can take half of 18. You can just type this all into your calculator. If you take 1/2 times 18 times 24. Reminder, if you have forgotten or don't quite know how to type in 1/2 into your calculator, calculators are different, or all your guys' calculators are different. But there's two main ways that you can type it into any of your calculators, regardless of which kind you have. So option number 1 is, instead of timesing by 1/2, you could times by 0.5, because 1/2 is 0.5. So that's option number 1. You could just take 0.5 times 18 times 24. Option number 2 is just type it in as 1 divided by 2. Okay, 1 divided by 2 and then times by 18 times 24. All right, and when you do that, you will get 216. And we're talking area, and it's millimeters, so your answer is going to be 216 millimeters squared, or square millimeters. Remember your units. Do not forget your units.